Hi. This work was done by Yassine Rabet primarily, and the slides are also Yassine's, and I get to present his slides. Unfortunately, he could not come here because of the visa issues. I'll try to do my best. So the motivation for that work came out of our group discussion where we were saying how measuring text similarity is really important for most of the tasks we do. Particularly, Asma Ben Abasha is working on question entailment and measuring how one question is similar to the other question or just question similarity. So given that, and given how we have seen in the recent years how sequences are so very important when measuring similarity. Then sort of in passing, because we are at a biomedical facility, we said, well, those people who do genetic sequences, they must have developed some sequence alignment methods. Should we look at those? And well, that was talk, but Yasin actually went and looked and developed this TextFlow method that takes into account takes as an example the DNA alignment sequences. That's for the canonical version, and then also he has developed a parameterized version, and I'll talk about it later. So where does it stand? Have I skipped the slide? Oh, sorry. So where does this stand, these TextFlow measures stand in the world of text similarity measures? It's sort of in its canonical form. It's firmly with the other standalone similarity measures like Jacquard or cosine distance. But when you add the parameters and train the parameters, then you can actually train it for a task or corpus-specific performance. So it crosses both of these worlds. So the idea, the way they align sequences, one of the methods to align sequences is to build a dot matrix. One sequence goes horizontally, the other sequence goes vertically, and you just start with the first letter in the source sequence and go across the row to match it to any matching letters in the target sequence. And what aligns is on the diagonal. Taking that idea and then saying, but we're not interested in just the diagonal, we are interested in the deltas. How far is the match from the diagonal? And just draw a curve through the matches and the diagonal. And then basically it's simple, you just want the area under the curve, and we all held our calculus and we were all taught how to split it into triangles and rectangles and get the area under the curve. And the one thing to note here is that the measure is asymmetric. You go from the source sequence to the target sequence, and to account for the differences in the length of the sequences, you need to adjust the position in the target sequence. So for example, if your source sequence is 10 and your target sequence is 15 words long, then you will adjust the position that is a perfect match to 2 in the target sequence instead of 3. So that's, in a nutshell, that's what the metric is in its canonical form. And then Yasin did a massive evaluation of how well it works on 3 different tasks. One is entailment, the other one is paraphrase, and the third one is ranking of sentences, or distance between sentences. And he used 5 corpora for the first task. There's only 1 that he found for paraphrases and 2 for ranking sentences. In terms of features, the sequences were represented with words, lemmas, and synset IDs, but if a synset ID is not present, then the lemma. And then these synset IDs in various sort of combinations, just the nouns, just verbs, or nouns and verbs. So these are the 7 features and the 9 data sets for the 3 tasks. And this is to illustrate that asymmetric nature of these TextFlow measure is actually important in terms of figuring out which aggregation of the text flow is better for a given task. So it turns out that for inference, the minimal distance is best, and then for the equivalence, it's also the minimal, and then for the ranking relevance, it's the average. This is an architecture to compare the baseline to the other metrics. To compare the canonical text flow to, I believe there is 9 baselines. And the inputs to all of these metrics are the same. And these are the results, the numbers are in the paper. But basically, what we're trying to illustrate here, TextFlow is very good on accuracy. It outperforms all the other known canonical distance metrics. It's okay on F1. It's really great on precision. And it's not so good on recall, so we're not showing recall here. So here's a parameters that might be of interest. How much do we award finding a word? How much do we penalize for missing a word? And how important is it, how much do we award finding a sequence? So alpha, beta, and gamma are these parameters that you can train. And what Yasin did, he actually trained these parameters on the training parts of all these corpora that I just listed. And the first layer is for training these 3 parameters, and then the experiment runs exactly like it was running for the canonical form, but now for the trained parametric form. And what's interesting, you basically get what you train for. So he trained for accuracy, and he got really good results for accuracy. But for the other metrics that he didn't train for, the results are not as good as the canonical form, but they're still good for F1, and they're still good for precision. So it's good, in retrospect, looking, okay, out of these metrics, TextFlow is really good for this, that, and the other, but how do we know which one is going to be stable for other tasks or other collections? And here, Yasin has developed these consistency metric to look at how these different distance measures perform on different tasks and perform on different collections. And basically, then he applied the metric to all the experiments, and he has shown that for the accuracy and F-score and precision, TextFlow is the most stable metric. It's consistent. So you get the best or the second best result with TextFlow, whereas the other metrics vary widely depending on the task and the collection. And the one metric that's more stable for recall is word overlap for all of these collections. So in conclusion, TextFlow is a new standalone similarity measure. It's asymmetric, and it allows you to, because of that, it allows you to adjust it for different tasks. You can train it for different, probably evaluation metrics and probably different collections, or you can use a canonic form. In the future, Yasin plans to experiment more with these and also maybe replace the softmax layer with the TextFlow. The code and all the experimental setup is available on GitHub. I don't think I have an address here, but it's in the paper. So that's it. Thank you.
Okay, thank you very much. We've got a few minutes for questions. And just to let you know, we're going to start the next talk a little bit early. It was actually a long paper. It should have been given an 18-minute slot, but it ended up with a 12-minute slot. But Dina has just given us a few extra minutes, and so we'll go ahead and take a few minutes for questions, but then we'll go ahead and start the next talk a little bit early to give Chin Hao time to do his whole 14-minute presentation. Can you wait for the microphone, please? Can you wait for the microphone, please?
I was wondering whether you've looked at the whole ROC curves for, say, for different documents at different thresholds, rather than fixed measures like accuracy, precision. It seems to me that that might complete the picture.
So yes, it's a very good point. We have not, right? So we should have included an ROC as one of the baselines. That's a very good point. I've given you even more minutes.
So then we'll go ahead and move on. Thank you. Thank our speaker again.